My name is Nadia Aman, and my ethics debate is about genetically modified organisms. GMO stands for genetically modified organism. GMO has become widely embraced as shorthand to refer to a plant or animal with new traits that have been created through modern genetic manipulation, often through transgenesis. This means genetic materials come from unrelated species. By changing an organism's genome, we can change its characteristics. DNA has been inserted into an organism's genetic code. Common examples of GMOs are GM crops used in agriculture and GM model organisms used in medical research. The genomes of organisms change naturally over time. Therefore, it's important to note what is not a GMO. For example, when organisms mate, offspring gets bit of DNA from both parents. Mutations can arise as a result of mistakes when DNA is copied. Environmental factors like UV radiation can also create changes in DNA. Bananas were domesticated 7,000 years ago. Wild bananas usually contain big, hard seeds and have little amounts of flesh. They have been selectively bred to have tiny, non-fertile seeds. Scientists from Queensland University of Technology have created biofortified bananas. These bananas have higher levels of vitamin C. They created using a technique that uses the existing banana DNA. In order to prevent vitamin A deficiency, also known as VAD, induced blindness and death among the millions of malnutritious people. VAD is responsible for an estimated 500,000 cases of blindness and up to 2 million deaths each year worldwide. Young children and pregnant women are most likely to be affected. This is especially devastating because VAD is one of the most easily cured illnesses and is treated with a simple vitamin supplement. It's argued GMO foods are a sustainable way to feed people, specifically in countries that lack access to nutrient-rich foods. The hardiness of GMO crops makes it so they can grow in marginal environments. The longer shelf life of GMO foods allows them to be shipped to remote areas. It decreases diseases by increasing vitamin intake. Hunger relief and medical aid programs need millions of dollars per country per year to run, while in contrast to supplying free technology transfer to support the developing country with crops yield. One example is the Golden Rice Project. The most widespread micronutrient deficiencies in humans are due to the lack of iron, zinc, and vitamin A. They are also a cause of major morbidity and mortality. A major goal of the Golden Rice Project is to supply consumers in rice-based societies with the recommended daily intake of vitamin A. In 2012, the World Health Organization reported that vitamin A could prevent about a third of all under 5 deaths, which amounts to up to 2.7 million children that could be saved from dying unnecessarily. Golden rice has the potential to complement existing efforts that seek to reduce blindness and other VAD-induced diseases. Those efforts include industrial fortification of basic foodstuff with vitamin A, distribution of vitamin supplements, and increasing consumption of other foods rich in vitamin A. Those programs are successful mainly in urban areas. It's difficult to fund a supplementation program. Small countries like Nepal or Ghana require about $2 million every year to run the campaigns. In spite of the negligible cost of a vitamin A capsule, a large country like India cannot afford to run countrywide programs because the cost becomes prohibitive. There is no guarantee that donors and governments will be able to carry on funding those programs year after year, such as UNICEF and Micronutrition Initiative. Biofortified crops, like golden rice, offer a long-term sustainable solution because they do not require recurrent and complicated logistic arrangements once they have been deployed. This is why biotechnology could improve the productivity and sustainability of developing countries' agriculture systems, supply greater quantities and availability of micronutrients. Food allergies are a growing problem in the United States. According to the Center for Disease Control and Prevention, the CDC, food allergies in children under 18 years of age have increased from 3.4% between 1997 and 1999 to 5.1% between 2009 and 2011. Some people believe that spike is linked to GM foods, but there is no evidence that GM foods in general are more likely to trigger allergic reactions than non-GM foods, according to a study from Harvard University. Others raise concerns about the transfer of specific proteins from one plant to another in genetic engineering. Proteins found in a relatively small number of foods cause most allergic reactions. Tree nuts are one of the most common triggers. Antibiotic-resistant bacteria resist antibiotics, making them hard to kill. Antibiotic-resistant germs may pass from the food to the person when consumed. According to the CDC, antibiotic-resistant germs infect 2 million people per year. Those infections kill at least 23,000 people per year. Scientists often modify seeds using antibiotic-resistant genes in the genetic engineering process. Some people wonder if there's a link between these GM foods and rising rates of antibiotic-resistant bacteria. In 2013, the journal Food and Chemical Toxicology retracted a paper that linked the herbicide Roundup and Roundup-tolerant GM corn to cancer and premature death in rats. Due to the concern about the paper, the journal's editor reviewed the researchers' raw data and peer review process. They found the researchers had used too few rats. The specific strain of rats was also prone to cancer, and the results were inconclusive. Since the paper has been republished in another journal, Environmental Sciences Europe, the controversy surrounding the study's findings has continued. According to the American Cancer Society, more research is needed to assess the potential long-term health effects of GM foods. Companies may have a hidden motive as well. Another source of opposition to the Golden Rice Project, mentioned in the previous slide, stems from questions regarding the motives of the project and its ties to several large biotech industries. Is it a ploy to enhance public support for GMOs, which could take funding away from cheaper, more sustainable solutions, or are they out to make a profit? The biotech industry's push of their technology raises concerns about their motives and contributes to the negative connotation of GM crops. Those involved in the Golden Rice Project reject that there are ties to biotech companies in which it would undermine their integrity. Here are my sources, and thanks for listening.